Okay, let's continue with an exercise to understand the theory better, as you know. So our first exercise is related with a question. Now you will continue with consider the following table. So you may assume that this table is obtained by an experiment. Okay, so find the best fit. So guys, this is the thing that you need to focus on in the question. Best fit means that you should find out here the best approximation to the given data set. Consider a straight line is also given. So the straight line, because guys, it means that the linear polynomial you will continue with. So your polynomial, your curve actually, your approximated curve will be like we did a1x, okay, and plus a0 form. So this is like here linear polynomial and trying to find out the best fit, which means that here you will use the previous analysis or the previous result to obtain a1 and a0. Okay. So we have analyzed the error in previous to get the error minimization, and we have obtained that. To find out here the minimum error, like we use here the polynomial whose degree is 1, can be obtained from this process, right? By solving this linear matrix equation. Okay, so to overcome this problem, first of all, I need to define here what is my summation of the data value square and also data value, and I'm filling here my blanks, as you know, from the data set. To do this, I advise you here using the table construction. So this is very useful for your approximation. Okay, for this reason I'm extremely advise this table construction for you. Okay, I wrote here xi values which is given in my data set and yi corresponding to the xi values. I'm copying and pasting it to my new table. On the other hand, I'm describing here x0, x1, x2, x3, x4, and x5 because it is important to discuss here how many points do we have, like this version. Now we will continue with, because guys, in my matrix equation, I'm seeing here xi square, so I need to find out what is my data point square version. On the other hand, on the right side, you are obtaining here x times y version. So for this reason, I'm adding here extra column, which gives me xi times yi as component-wise version. On my table, I'm writing all summation of the values in the last row, as you can see from my table. This table will be helpful for substituting your data points in your matrix equation. This will be better for your calculation. For this reason, I'm extremely suggest create this table form. Okay, and this is also useful after seeing the linearization of the nonlinear data set. This will be better for your calculation. Okay, for this reason, if you are familiar to write it, then it is better for your analysis part. Okay, now as you know from the function matrix equation, the expression, it says you that on the first row, first column, I'm substituting xi square version. So addition here is 3.64. So I'm writing here 3.64. Continue with the summation of xi's. So I'm going to the xi column and I'm writing my last row, which gives me my summation of all data points will give me here 4.2. So I'm writing here 4.2. Now it is also same. So I'm copying my diagonal entry here. 4.2 on the diagonal of this point. So it is turning to again 4.2 here. and you will have here one addition. It means that because of this, I have actually discussed in previous that guys, you are adding one how many times? How many times it's coming from there? I'm adding starting with 1 plus 1 plus 1 plus 1 plus 1 plus. So how many points do you have here? 6 points, right? So 1, 2, 3, 4, 5, 6. So 6 points, 6 times you are adding here 1. Totally, it gives you 6. So on the right side, your a1 and a0 are unknown for you, and this vector is unknown, I mean. And on the right side, you should continue with summation of x times y. So I'm going to x times y columns, and I'm seeing here my addition is constructed by, my table. So I'm copying my x times y all summation to my first row, first column of my right side. On the other hand, we also have here in my second row, first column, I'm seeing here yi summation. So here I'm going to the yi column, and I'm going to see here my summation of yi, all yi's. So here I'm writing here yi points of the summation. Okay. So you will solve this expression. Of course, here you can use your calculator, or you can use your programs if you are, you're appropriate to use it, like MATLAB. Okay, you can solve by using them. Or if it is not okay for you, you can also use here the elimination technique. So here, because some of you does not see the linear algebra course, I'm writing here the elimination technique. So how do you use it? So for this reason, I'm writing here 4.2 times. I'm eliminating here a1 option, and finally you are getting a0 like. Of course, you will use some tedious calculations. For this reason, you need to be careful. So if you are using here some programs here to calculate them, it would be better for your calculation. Of course, it is possible, So an A1 will be obtained by substitution of A0 in one equation. Does not matter whatever you use here, okay? Now, at the end of this process, after, we have an exercise, but it is asking that find the best fit to the given data set. It is not saying to you that find A1 and A0. You should define your fit, okay, your curve at the end. So your curve will be written as here. I am defining my curve, which is a straight line, which is given in my equation. So the question, so we will continue with here our writing our method or our polynomial at the end by describing here our A1 and A0. Okay, in the next question, I'm giving here like an homework to you. But let us discuss together again on the exercise. Consider a straight line which is the best fit for your following table. Again, you are having here, constructing here your data set. I'm giving this question because, guys, to show you here, not only here the x values here all the time positive. It can be sometimes negative, okay? So what are we doing if we have such this expression? Now, please try to do the same table, create the same table, please. This should be better for your calculation. You should write down here xi, yi, xi squared, and x times y. Because you are again using the straight line, it means that you're just trying to find out a1 and a0, like your p polynomial is a1 x time plus a0. So we have also analyzed it in previous, so I'm just using the results that I'm obtaining in my analysis. So here is the values you are creating here, a1 and a0 values, and you should define here your polynomial x. This is like an homework, okay? Okay, guys. Let's continue with what about nonlinear data? Okay, look at here. When you are considering the linearization of nonlinear data, there is a big problem for us. The big question here is that when we have a nonlinear data set, what will we do? Because guys, if you have nonlinear data and you are trying to approximate to that data like a quadratic function or linear function or cubic function, if your behavior does not fix with your choosing polynomial, then your error cannot be minimized. So for this reason, you should be careful for your choosing of the data, choosing of your polynomial case and your analysis. Here we have two ways. The first way, you will choose here your polynomial or function. Sorry, it's not a polynomial. Maybe we can choose here an exponential curve or a powered curve like this version. So for this reason, I can say that here in way one, if you are choosing the way one, you need to focus on here. You are choosing a curve and you will do the same analysis that we discussed in previous. But now your error will be here not only by calculating here the error propagation, and you are creating here the error propagation and your unknown variables and discussing here all the derivatives, your error with respect to these unknown variables, and if the derivative will be 0, finally you will deal with your solution. So it is very complicated, but it is more reliable than the other one. Okay, way 2. Now, here we didn't change our curve and there is no more problem in your system in way 1, but it consists of a lot of calculations, and so I think it is more complicated for students. For this reason, we are giving here another way. In the second way, we linearize our curve. The linearization gives rise to a linear version. For this reason, if you are obtaining a linear equation, then you can say that from now on, we can use the previous results that we have obtained in the previous analysis. So then it is very easy to implement it. But here, need to note that, guys, it is it's getting more easier our calculations, but it is less reliable than the way 1. So you need to be careful for them. And this is our the thing in the linear numerical methods. If you have chosen a method or any way, if you chosen a way, you need to spend something. Okay, you need to pay something. For this reason, you will continue with the linearization for our calculation, because to make it easier for our calculation version. So I'm continuing with way 2. Okay. So first of all, it is passing through how we linearize any curve. So do not forget one more thing I wish to say here, guys. I want to emphasize it actually. When you are dealing with here your curve by the linearization, actually you are getting here an error. On the other hand, you will have here the error because of your approximation. So your error will be getting bigger actually. Even though you are saying we are minimizing our error, but because of the linearization, it is getting your bigger error than you calculated in your analysis. Okay, need to be known this one. Okay. So how can we linearize the curve? To do this, guys, I'm giving here 2 exercises to linearize some curves. Consider the curve y equals to c times exponential bx. Linearize the given curve. So y will become here c times exponential bx. By doing here the linearization means that your main purpose here is to put this expression in terms of ax plus, sorry for this reason, it should be plus, okay, so plus b will be equal to capital Y. So our main purpose is to put our equation into that equation, and now you will discuss here your new, this is your new variable, this is your new variable. All these things actually we can say that they are new variable for us. Okay, how do we do this? Let's see here all the steps of the solution. Here is y equals to, we are taking here our equation. So my main purpose here is to get your x expression as you know in your in your line. So I'm writing here taken ln to get rid of the power, and it is converting to now bx form. So for this reason ln y becomes ln c plus ln exponential bx. By using some properties of the logarithmic functions, if we are having here this multiplication, then it can be written addition. But if there is an addition, guys, you cannot writing separately, you cannot do this, okay? So we are defining here ln y like capital Y. Your ln c defines you a0, and b is your a1, and your small x value will give you big X. Now I am redefining all the variables according to the given function. Okay? Now, one more expression to linearize it. Let's see. Guys, I'm choosing here these functions like the exponential function and this function, saturation function, because they are generally used some the problems arises in engineering fields, also the science fields, okay, the field of science. For this reason I'm choosing them. The saturation function is defined like y equals to x divided by ax plus b. So linearize the curve. Let's do this. How can we get rid of this division? It is actually, guys, your main purpose is to put, again, let me write down, it should be ax plus b. So I need to see my x variable as this form, okay? So your main expression will become here, how can you define your x value like this one, which is a function of actually small x. This will be a function of small y. Okay, let me say classify myself as f1 and f2. So let's start with the linearization. How do we do this? This is not a power function. For this reason, just using the reciprocal. Okay, I type the reciprocal, and after doing it, we can write down here a plus. Now you have obtained that some a0 value and times b times 1 over x. Now we can define here, this is my big Y, it is my big X. Whereas here your a and b values will give you here a0 and a1 values respectively. So up to here, I just give here the linearization forms and how do we linearize our curves. From now on, we will discuss here the exercise for the least square methods or for the linearization of nonlinear data. Okay, see you in the next video.